Hey, we're here with Conrad, a plasma physicist for the Magnetospheric Multiscale mission, or MMS. How you doing, Conrad?
Fine, how are you?
Now, I understand you've been with this mission for a very long time.
Yes, first time I worked on MMS was in 1999, thereabouts. I worked on it when it was still a sort of mission concept, gleam in somebody's eye. It wasn't really, hadn't received any confirmation from headquarters. It hadn't been authorized for any kind of spending. It was just, can we pull this off?
Now, before we get into the space physics of it, let's talk about the health of the four spacecraft. How are they doing right now?
They're doing quite well. They have plenty of fuel. They know how to talk to home, that is to say, how to talk to the three networks that support them, the Deep Space Network, the Space Network, and the Near Earth Network. They use each of those networks in different parts of their orbit. They're sound in terms of power and thermal. They're nice and toasty warm. All the instrumentation is working well. They're performing fabulously.
I'm sure you're collecting a lot of data. Just how much data are you receiving from MMS on a daily basis?
Well, there's a huge amount of data. Daily is sort of a hard measure to pick, but in the last 6 months, during what we called Phase A, the primary time in which the formation was between the Earth and the Sun at its apogee, we collected tens of terabytes of data. And that actually is only a fraction of what was actually collected by the instrumentation. Generally speaking, each observatory collects an awful lot of data, and then onboard algorithms and people on the ground look through that data and find the single best candidates to bring down. And then those are brought down, and the ones that maybe aren't quite so interesting are brought down when they can be brought down, etc.
Is each spacecraft collecting the same type of data?
It's collecting the same type of data, but it's collecting it in a different place in the orbit. So that enables each of the spacecraft to sort of do a cross comparison. Hey, what are you seeing over here? I'm seeing something. Are you seeing it? Nope, I'm seeing it a few seconds, or more appropriately, a few fractions of a second later. And that change in time and position allows the MMS formation to investigate things like magnetic reconnection or ionospheric outflow in a way that a single spacecraft mission can't.
Now, how do you sift through all that data that you get?
So,
it's a large Excel spreadsheet, isn't it?
Yes, exactly. No, I mean, there are layers, as in anything. Any endeavor that you do, large or small in life, both in science or whatever, you do by taking the problem apart, putting it into manageable steps, and then working those manageable steps one at a time. So the initial survey data is called Quick Look, and it just gives a general idea of what the magnetic field is doing, what the density is doing for the electrons and the ions, and what patterns in terms of how the electrons and ions are moving. Sometimes the electrons are strongly aligned along the magnetic field lines. Sometimes they're more populating the area perpendicular. So what we do is we sort of survey, look for an interesting candidate, and then we start drilling down. And drilling down is a combination of just playing with the data by hand, and then as you learn what you're looking for, you teach a computer program to look for that for you.
Okay.
And then you turn that automation loose, and out comes, raw data, plots, figures that allow you to have an understanding of what's happening.